IEEE 802.1W standard is what? Rapid spanning tree protocol. Rapid means faster. We saw in the previous class with the demo I showed you. In the demo I showed you very well that the convergence was taking much time. So first thing is I'm going to create these two VLANs on all four switches. How do we do that? Please pay attention. I'm going to also teach you something new in this class, not the same old previous class syllabus, a little bit more. This is how we log into a switch. You have to type enable. That takes you to the mode called enable mode. This is what called as enable mode because you use the word enable to get into the mode. What about this mode then? The one with the greater than symbol is what called as user mode. User mode, enable mode. This is same for router also. Right? So in enable mode, you can only use show commands like show spanning tree, show VLANs. You cannot do any configuration here. You see here now, show VLANs. When I type, it shows the VLANs that are currently present. Currently, there is a VLAN called VLAN number 1, and to which all the interfaces are mapped. We have seen these things earlier. What about these VLANs? These are all not considered. Why? These technologies are no more supported. FDDI, token ring, these are all very old technologies. For those technologies, these VLANs were reserved as per the standard. Even though these technologies are no more, we have to still keep it because it's a standard. Because it's a standard, you have to keep it. That's the procedure. That's the standard. Even say, for example, the passport. When you go and take another passport, because your old passport, all the pages are stamped already. You go and add for extra book, extra pages, you add another passport. You have to carry both now. Even though this old passport is full and you cannot stamp anymore, you need to still carry this old passport along with the new extended passport. Otherwise, there will be a big problem for us in the immigration. Likewise. Because it's a standard, you have to carry these things always, even though you don't support it. Every vendor who creates or develops an operating system for a switch, they follow a standard. In that standard, it is written, hey, 1002, reserve it for FDDI. 1005, reserve it for token ring net default. You know? So they put it there. So never mind these four VLANs. That's what I want to say. And don't try to use these numbers for VLANs, because they're all reserved for a purpose. Though they are not in use today, we need to ignore them, should not use them. So show VLAN brief is better command than show it. Show VLAN brief shows everything in a single page. Next, do I have VLAN 100, 200? No. Our plan is to take this interface and give it to VLAN 100. Take this interface and give it to VLAN 200. That's our plan. I'm going to do that now. You see, VLAN 100, VLAN 200. You see, to configure, I was not doing in the enable mode. I used the command called config t, config terminal. Santosh, have you learned these things earlier? The modes and all, enable mode, user mode, config
Yes,
mode. Have you heard before, learned before? Okay,
yes,
fine.
I have
So you are
learned.
not
Yes,
that
sir.
new to this, you are experienced, fine. So we are in the configuration mode and we have created two VLANs, but we have not assigned any interface. You see, show VLAN brief now. We do have these two VLANs which was not earlier seen, but no interface has been allocated. Our plan is to take this 01, give it here. How to do that? Interface F0/1, switchboard access VLAN 100. This is how we make this membership, VLAN membership, make this interface to be a member of VLAN 100. Next. I was also saying the other day, you need to configure the port as an access port if you're allocating an interface to a particular VLAN. This port, this interface, this port is a member of a single VLAN. So you have to say switch port mode access. About the modes, I'm going to teach you in detail in another class. But as of now, what I want to say is, if this is not going to be in between the switch, if this port is not in between the switch, then it should be access. Between the switches, you need to configure as a trunk. Okay, next. Interface F0/2, switchboard mode access, switchboard access VLAN 200. Now, VLAN membership is over. Show VLAN brief. You can see now F01 is in VLAN 100, F02 is in VLAN 200. Now, one more thing is, all the switches will have same name that may confuse us. So let us give a name. Host name, that's the command. Host name is one keyword. You see, even to give host name, I have to come inside the configuration mode, config mode. The command is config t, switch_1. All right, now how do we save this? One way is copy, run, start. I'm going to explain you the running configuration, startup configuration later. So as of now, how do we save it? We save it by typing the command copy and start or WR. WR is also okay. WR means write to memory. You can use any one of this. Differences I'll teach you later. Now, I'll move on to, this is named as switch 1. This is switch 2. Okay. So switch 2 also should have those VLANs, those two VLANs. host name switch underscore 2, and creating VLAN is VLAN 100, VLAN 200. See, I'm creating VLAN 100 and then coming out of it and then creating VLAN 200. This is one way. This is the supported way in the simulator. But in the real switches, what we do, let me show you what we do. Switch 3. Host name switch underscore 3. So what we do in the real world, we say VLAN 100, comma 200. You can type this, it will work. But in the simulator, it won't work. The simulator, it won't work. You have to create one by one. VLAN 100, VLAN 200. Okay. Next thing is, I remember I was telling you, between the switches, you need a trunk port. This 2 port should be trunk port. Likewise, this 2 port should be trunk port. And one thing I want to add something new which you have not known in the previous classes. If you configure one side, the other end will be automatically trunking through negotiation. I repeat, if you configure one end of the wire as a trunk, the other end will become trunk automatically. Let me show you that. See, on switch 1, you ask switch 1, show interface trunk. It says there is no interface trunking, but after I finish configuring switch 2 and switch 3, I'll come back and show you. You see switch 2, I'm saying interface. There is a command called range command. Why do I use range? Because I'm going to configure both F01 and F02 as trunk. So I want to do it in one shot. So I say range. Instead of going individually to each port, I can use range command and get into both the ports and say switch port mode trunk. Exit. Next. Did anyone get logged off? Okay. Interface range F0/1-2 switch port mode trunk. You see, I just configured on switch 3 and
Yeah,
switch 2.
myself, I
You saw
got
me
logged off.
configuring these commands on switch 3 and switch 2. Switch 2 and switch 3. Switch 3. I did not configure this on switch 1, but I told you if you configure on one end of the wire, the other end will become trunk automatically. Let's go and verify that. You see on switch 1, you see it's trunking. On switch 1, we did not configure. It is trunking because of N. You know what this N stands for? This N won't be there in switch 2. If you check the switch 2 show command, show interface trunk, here you will not see that N. Do you see N here? But here you will see. On switch 1, you will see N. On switch 2 and 3, you will not see N. You know why? Because in switch 2 and 3, we configured manually. It's not through negotiation. Whereas here, it is negotiation. The negotiation made this port to be a trunk port. When I configure switch 2 as a trunk, it came to switch 1 and negotiated. And negotiation was successful. That's why it is trunking. More about this is coming later. Okay, switch 2 is trunking. Switch 3 is also trunking. And VLANs are already created. Let's go to switch 4 now. Okay, now on switch 4, interface, sorry, let's do VLAN 100, VLAN 200. Next thing is what I need to allocate the interfaces, right? So if you notice here, F01 should be a member of 100 and F02 should be a member of 200. So as an interface F0/1, switch port mode access, switch port access VLAN 100, interface F0/2, switch port mode access, switch port access VLAN 200. Okay, we finished. Verify. Here we have not configured trunk, but because of negotiation, this also should have trunk. Show interface trunk. Yep. This also through negotiation trunking, and it is allowing these VLANs on the trunk link. Now what is left is I need to go and assign IP address and try pinging from these computers. I'm on this computer to the left, which is 10.0.0.1, and go to test command prompt and type ipconfig to verify whether it has taken that IP address. Verification is good, no? Ipconfig, yes. This is the IP address I gave. Gateway is not needed because we are not doing routing. Only when you do routing, only when you move traffic from one network to another network, which we called as routing, we need gateway. Router's address will be gateway. We don't have a router. Okay, what is next? Let's go here. .0.0.2. Okay, then we need to go and verify. Just close this place and then click on command prompt and ipconfig. You see there. Now, if I ping from here, I should be able to ping the other end. So there is one command called -t. What does that mean? It means timelessly ping. It means you keep on pinging. Sorry. -t should come in the beginning. If it don't work in the beginning, then you put it in the last. See, it will be keep on pinging. It won't stop. It will be keep on pinging. What is pinger? Packet Internet Grouper. It sends the echo request packet using ICMP protocol to the destination whom you want to reach. And if the destination is available and ready to communicate, it will reply back using ICMP reply. So you're getting replies, ICMP replies, which means you're able to reach from this to that computer. Now, I'm going to this computer now here, 20.0.0.1, and verify the command prompt ipconfig. Okay, it's given. I'm going to say ping -t 20. Actually, 20.0.0.2 doesn't exist, so you won't get a reply. But as soon as I finish configuring 20.0.0.2, you will start getting replies. So as of now, let's minimize this and go here and configure 20002. And you see, we have configured. Now if you go and check, the ping would have started. Look at this. For some ping, it didn't happen. But as soon as I put the IP address here, it started pinging and you started getting reply. Good. Likewise, you can also ping from here 20001. What do you understand from here? VLANs are properly configured. Interfaces are properly functioning. PCs are properly assigned with an IP address. That's the proof. Fine. What is next? Our aim is to verify that per VLAN spanning tree is slow. We need rapid spanning tree. Per VLAN spanning tree, which is right now running, is slow. Why do I say per VLAN spanning tree is running? Let me show you. If you see the switch, this goes spanning tree. For 100, there's a separate instant. For 200, there is another instant. For each VLAN, there is a separate instant of spanning tree running. That's why we call it as per VLAN spanning tree. So we are going to see that per VLAN spanning tree is slow. That is the second point we are going to see. First point, advantage of per VLAN spanning tree. Right now there is a block here. I can see that red color. If you want, I can show you on the command line. Switch to. You see, there's a block. F01 is BLK, blocking. Not only for VLAN 200, even for VLAN 100 it is blocking. And for VLAN 100, it is blocking. It is blocking for both 100 and 200. It's blocking. What does that mean? It means that currently the ping that you have generated, this pings that is going on, the ping that is going on between these computers, they're all going through only one path. This also goes like this. This also goes like this. So this path is totally idle, totally unused. What are we going to do? Because it is per VLAN spanning tree, because there is separate instant of spanning tree, I can do like this. I'll say for VLAN 100, priority 0. Here I'll say for VLAN 200, priority 0. What does that mean? It means that this is the root switch for 200. And this is the root switch for VLAN 100. Which means for VLAN 100, this will not block. Then you will see all VLAN 100 passing through the upper path, all 200 will pass through the below path. So both the paths are utilized. That's what we are going to see. Before I do that, we did this in the previous class, just as a reminder. I'm doing it again to remind you. If you notice here, switch 2 is blocking for both 200 as well as 100. Rapid spanning tree protocol is faster. We just saw that convergence takes 50 seconds, which is not good. The conversion time should not be more than 300 milliseconds. In case if you have voice, you need to have less than 300 milliseconds. So this spanning tree protocol, which we just saw, per wheeler spanning tree, is not good. It's slow. We need to switch to rapid spanning tree where there will be less convergence time. What is convergence? Adapting to the network changes. What convergence time? Adapting to the network change. Rapid spanning tree is faster, as the word says. You know why? Because the rapid spanning tree is not timer based. It is not timer based. You saw now the normal spanning tree is timer based. It took 20 seconds to know that there is a link failure, and then 15 seconds of listening, 15 seconds of learning. So it took totally 50 seconds in total to converge. This timer is not good. I've seen in some metros. Wherever I have seen, this is how it was. Even in the midnight, 2 o'clock, when I go to station, the metro doors will open. No one is there actually to get into that metro. It will stop for a period of time, maybe I think 30 seconds. And then the door will close. And then the metro train will move, which is called timer based. Whether there is a person or not to get into, it is going to stop for that period of time, keep the door open and wait, which is a waste of time. Rapid spanning tree will not wait for 15 seconds in listening, simply when there is nothing to listen. In 15 seconds of learning, when there is nothing to learn, learning the topology change. So as soon as the BPDU comes, they will learn. They don't need to wait for 15 seconds to learn. So the timer is removed. Not only that, the decision to make it forward can be done by any device which has got the blocking. Whereas in the spanning tree, which we just saw, per wheeler spanning tree, the root switch is the one which has to decide. Okay, so let us go and enable rapid spanning tree now. Enabling is very easy. You see, spanning tree mode rapid. That's all. One thing you need to know that if you enable rapid spanning tree, it is per VLAN. So it's the same per VLAN only, but rapid per VLAN. It is not going to take 50 seconds. It is not timer based. Need to enable it on every switch, not just on one. Command is what? Spanning tree mode, rapid per VLAN spanning tree. In Cisco only, when you enable rapid, it will enable per VLAN by default. But in the other vendors, you have to do separately. Spanning tree mode, rapid. Then switch 4. Oh no. Spanning tree mode, rapid. Okay. Now we have enabled rapid spanning tree on all the switches. Yeah, on all the switches. And some packets we might have lost because it's converging now. We were into per VLAN before. Now we have switched to rapid, so it will take some time. But once it is converged, it is going to be faster. Wait some time. Okay, now it is converged. From now on, it's going to be very fast. You're going to see that. Let me go and cut the wire again. All right, I'm showing one going to 20, another one going to 10. Now I'm going to cut the wire, this wire. Cut the wire. You see, when I cut the wire, 10 was dropping packet, many packets. But this time, how many? Last time it was the 8 packet and then 5 packet. This time, oh no, it should not be this long. Sorry, this is not as per the expected. What? I know why. It's my mistake. Let me connect the wire back and teach you something which I should have configured. Okay, what is the missing piece? Missing piece is, see, we have enabled rapid spanning tree. That's true. But the problem is the BPU is going even to these computers. Can computer respond to switch BPDU? No. But to decide, to take decision on the switches, either they should get the response for the BPDU. What is BPDU? Bridge Protocol Data Unit. That is the one which is taking the topology change notification. Either you should have a BPDU response or the BPDU response to timeout. That's why it is waiting. It is waiting for the timeout to happen. So what is the best way? On all the host ports, what is host ports? These ports where the end devices or computers are connected. These are all host ports. Host ports. On all the host ports, we need to enable only on the host port. I repeat, not on that trunk port. What is trunk port? Can someone say what is trunk port? What is trunk port? Yeah, the link between two. Thank you. The link between two switches we call it as trunk port. The link between two switches. What, Santosh? What happened to you? Silent. So do not enable port fast on the trunk port. Enable port fast only
For
on the
interacting
access
with
port.
two switches.
This is an access port. All the end host connected ports are called as access port. You enable an option called port fast, a feature called port fast. What does that mean? In that port, BPU response are not needed to take a decision. To make the blocking port to forward, those ports response is not needed because they're not connected in between switches. So I'm going to quickly enable port fast. So remember, whenever you enable rapid spanning tree, you need to go to the access ports and say spanning tree port fast. That's it. You see, as soon as I enable port fast, it is showing a warning. Hey, don't enable if you are connecting to another switches. You cannot enable if you are connecting to other switches. Okay. Okay. Now, this is just a warning. It's not a error or something. It's not a mistake, it's just warning. I have to go and configure port first, even in this switch for 1 and 2. Sorry, interface range F0/1 2. Spanning tree, port first. That's all. After you enable this port first, switches won't wait for them to respond on this port. BPD response are not expected. Okay, now let's go back and verify. This is pinging. This is also pinging. Pinging. Both of them are pinging. Both of them are pinging. As they're pinging, I'm going to cut the wire again. I cut the wire. And now go to the computer. Look at this. One packet dropped. Oh no, it should not take this long. I think the simulator is not accurate. It should not take this long. No. It'll be very fast actually. It's not happening. It's not happening. Mhm. Let me see when it pings. You won't even lose one packet in the real world. Something is wrong. It's not because of spanning tree. Even parallel spanning tree by this time it was pinging. This is something else. Okay, let me go and check. Did I enable rapid spanning tree here? Show spanning tree. Yes, rapid spanning tree is enabled. Let me check here. Show spanning tree. Yes. What about other switch? What about the last switch?
Yeah.
I think I did not enable here. No, I have enabled everywhere. So this is not a problem of ours. This is a problem. Look at this. It didn't ping at all. It's the problem of the switch, the simulator. So rapid spanning tree is really fast. It won't take this long. Okay, now I have connected. Let's see how quickly it pings. Okay, it's pinging faster. But after connecting, it is faster. But when I disconnect also, it should be faster. It should swap the traffic to the other path. It was not doing. It is only the simulator mistake. It's not the real device behavior. Okay, rapid spanning tree is faster. What is the reason? It is not timer based. All right. So we'll stop here. We'll have another spanning tree called MST,
It is
multiple
now.
VLAN spanning tree protocol, which is according to IEEE 802.1s standard, which we'll see in our next class. Any question from today's class? Santosh, do you have any question? All right.
No, sir. No.